Joe Woznicki, a researcher at Purdue University. I'm a master's student, and I'm going to go over my poster here a little bit about some of the research that I'm doing at Purdue with Dr. Jeff Trapp. Basically, my poster is entitled Upscale Feedbacks Modeling and Mesoscale Predictability Experiment Observations. So I was a part of the MPEX field project this summer, and it's a storm chase project from May 15th to June 15th of this past spring. And we looked at these storms, and we launched weather balloons around them to gauge their effect on the atmosphere in their wake as they pass through a certain area. So basically, we had a team of researchers from Colorado State, Purdue, the National Severe Storms Lab, and Texas A&M, and we all got together and coordinated these launches around the storms so we could get a feel for the environment before and after the storm had passed. So just kind of how the storms would modify their environment. So first a kind of background behind this research. MCSs in their wake, they produce these big potential vorticity maxes and really alter their environment and can hurt or harm numerical weather prediction in the wake, and it's kind of hard to predict what's going to happen. So we thought, hey, well, maybe the supercells do the same thing to their environment. So that was kind of the basis behind this research. So basically, we had these radiosonde systems, and we were able to be mobile around the storms and move to wherever we thought would be the best locations to kind of gauge where exactly these upscale feedbacks or modifications of the atmosphere were happening. So some preliminary results that we have. This map down here shows kind of our positioning. You can see CSU, Purdue, and NSSL here. And NSSL is in the direct wake of the supercell. And this is on May 20th, 2013. So basically, we found that CAPE and lapse rates are really decreased. CAPE is almost annihilated in the direct wake of the storm, which is what you would expect. But on the northern and southern flanks of the storm, just directly outside of it, these two parameters, CAPE and lapse rate, really aren't affected that much. So it's a really localized effect of what these supercells do. I also did some idealized modeling with the CM1 model, and we looked at just a basic, perfect, idealized supercell and how it would affect the environment. And we found that at the mid-levels of the atmosphere, it generates potential vorticity on a very localized scale to the storm, which some previous research shows that these supercells produce these big PV maxima that are kind of conserved with the flow and are very conserved as they go through the atmosphere. And we actually didn't find that in this idealized modeling, and it'll be good. Some more research needs to be done on our actual observations from MPEX to see what exactly is going on, and if the CM1 model really has got a good handle on this. But it does show us the CAPE has been annihilated in the wake, and also shear and lapse rates. It shows that, like we observed, that it's a really localized effect and is not a very large scale feedback for those two parameters. And future work will just include more analyses of the observations, just to get a better handle on the upscale feedbacks.